Okay, have your card handy today too. We'll be adding to the card. We are looking at lateral area and surface area again. Pyramids and cones. Right on the overhead. Okay, good. Alright, so we've got to talk about the parts of the pyramid first. They talk about the vertex on a pyramid. Which vertex do you think is the vertex?
The top one.
The top one. Each corner is a vertex, but they refer to this one as the vertex. So it's the point opposite the base. That's the vertex. And our formula is only going to be for regular pyramids today. So what makes a pyramid a regular pyramid is that the base is a regular polygon. What makes a polygon a regular polygon? What makes it a regular polygon? All sides are the same, all angles are the same. So your base could never be like an oblong rectangle. It would have to be a square, an equilateral triangle, a regular hexagon. So the base has to be regular. What that does is it makes all lateral faces then are, what's the relationship between all these triangles then?
Congruent.
They're all congruent. Are congruent triangle. Okay. If I asked you for how tall that pyramid is, where is the height at? Why do you guys have a headphone on? Take it out. You're that good you can listen to that and me and understand everything? No. I know, it's totally disrespectful. Anyway, the height. If I asked you to draw in the height, what would you do? Straight down the middle, right? Okay, so we've got a straight down height down the middle here. So, like a drill going right down to the middle, hitting the center down here. Right angle. That's our height. What word do we use for height? What word does geometry use for height? Altitude. So the altitude, we're going to use h. It's the perpendicular distance from the vertex to the base. Okay, now we're going back. Now we talk slant height. Slant height, they use lowercase l for slant height. Well, I'm going to make mine like the cursive L, because otherwise if I just put a line, it looks like a 1. So they use lowercase l for slant height. What this is the distance from the vertex to the midpoint of the base edge. So I'm coming from the vertex to a midpoint. Right down the middle of the triangle. That's your slant height. Why do you think we need that piece of information if we're talking surface areas and lateral areas? What is that?
So we can figure out
It's the height of the triangle, isn't it? And that's in the area formula for a triangle. That's why we need that, because that's going to help us get the areas of all the triangle pieces. So slant height is running at the angle down the middle of the triangle. Height is how tall the thing actually is. So we got two different heights that we're going to be working with. Okay, so we're going to draw the next, and then we're going to come up with the lateral area and surface area formulas. So, because this is a regular pyramid, what shape is this base? It's a square. That's a square. And then off of each one of those, we've got a triangle.
Oh, we're drawing the net?
Yep, we're drawing the net. And then the parts that I know, the base edge here was 8. And the slant height coming down the middle of the triangle is 10. So, labeling this thing up, we got the 8 all the way around the square. And then each height of the triangle is 10. Okay, we're going to do lateral area in an obnoxious way so we can see where the formula comes from. Okay, so lateral area. Remember, what is lateral area compared to surface area? What's the difference between them? Is, what'd you say? Without the bases. So when we do lateral area of a pyramid, we're doing the lateral area, or the area of all of the triangles. So it's the 4 triangles. Okay, the quick way to do this would be to find the area of one triangle and multiply by 4, correct?
Yeah.
But that won't show us where the formula comes from. So what I want to do is do each one separately, not do any calculating. So it's 1/2 times 8 times 10. Plus 1/2 times 8 times 10. Plus 1/2 times 8 times 10. See how this is obnoxious?
Yeah.
One more time. 1/2 times 8 times 10. Okay, now, I want you to think of this as 4 baskets. Basket, basket. Okay, I want to factor out the 1/2 and the 10 from each of them. What's going to be left in each basket? 8. So I've got 8 plus what's in the next basket, 8 plus what's in the next basket, plus the last basket. Okay, so now I want you to tell me, I don't even really want the answer here. I want to know what each of these represent, what each value represents. What is the 10 representing in this pyramid?
Height.
Not height, glance height. What is 8 plus 8 plus 8 plus 8 representing? Base. What about the base? The perimeter of the base. Agree it's adding up the 8 all the way around? So that's the perimeter of the base. And that's our formula for lateral area of a pyramid. So the lateral area is 1/2. They put the P first, 1/2 PL, it doesn't matter. PL. So P, yeah.
It's like in the figures, where did, why, how did the 10 get all of this?
Because that's how I make it match the formula that they give. I'm just trying to show you where this formula came from. And if we factor the 1/2 and the 10 out of all 4 baskets, then it matches the formula. I'm just showing you how they came up with the formula. Would you know to only take out the 1/2 and the 10 on your own? No. Okay, so I'm just trying to tie in where this formula is coming from.
But how,
What?
okay, I don't get, I understand the
Mhm.
process, but I don't understand how that formula would work for all 4. To me, it looks like it would only work for the one, not all 4.
Because of this, because it's taking 8 4 times. Because it's doing all 4 triangles. By doing the perimeter, it's getting all of the bases totaled up, and then multiplying by the height of the triangle and then the 1/2. So it's doing this. This is the quick way to do this, is all it is. So like on an ACT, if they're doing an area problem, and you say, God, I don't remember the area, the lateral area of a pyramid. Well, just draw the net. It's just adding all the pieces up. So you don't remember the shortcut, but you know the process to get there. So I'm just trying to tie in this formula with what's going on. Okay, and like I said, I don't even really care what the answer is. I want to come up with a formula. Surface area is lateral area plus what? The base. How many bases does the pyramid have? Just 1 this time. Yesterday when we were doing the prisms, there was 2 bases, but this time we only have 1 base. So it's just big B. So your formula is lateral area plus the area of the base. So again, we might want to put, I don't know if you need to know what these stand for. P is perimeter of the base. L is slant height. And big V is area of the base. So let's add those two formulas to your card so that they're handy. Okay, so the pyramid and the cone are on the back side. Pyramid, we just finished. So the LA is 1/2 PL times P times L. And again, if you want to tell yourself what the P stands for, what the L stands for, like I did here, go ahead and add that to your card. If you're confident, oh, I know P is perimeter of the base, and I know L is slant height, I'm not going to bother messing up my card. You write on there what you need to write on there so you remember what those are. And then surface area is LA plus big B, area of the base. Good? Okay, the cone. What's the net look like for the cone?
Circle with a
Circle?
oblong shape.
Yeah, that kind of pie piece. Kind of looks like a piece of pie. Kind of. Kind of this. And then it comes to a point here.
Kind of like a, baseball.
Yeah, baseball field.
Yep.
Home plate, the line's going out, outfield fence. Yeah, I definitely see baseball. Okay, so back over here we need to label some things up. We got the radius here. What do you call this one here that's coming from the vertex down?
That is your,
That's your altitude. What letter have we been using for altitude all the time? H. Okay. This angle distance along here, just like the pyramid, that's your slant height. So we got two heights working here, the actual altitude height and then the slant height. So we got an L on this one also. That's why we grouped these two together. Okay, so the lateral area is just the area of this piece without the circle base. And this formula is not easy to develop, so I'm just going to tell you what it is. Pi RL. And then for surface area, that's LA plus, what do I need to add on to get surface area of a, what shape is the base every time on a cone? Always a circle. So I can actually put the formula in for this one. So it's LA plus pi r squared. I couldn't put something in for the base up here because the base shape can change from a square to a triangle to a hexagon to whatever. But this one stays. Okay, add those two to your card. Again, the rest of the chapter after this quiz, we're going to come back and do volumes in all of these too. So leave room for one more formula in each section. So cone, LA, pi RL, LA plus pi r squared. Alright, let's practice them. We're just going to do the next three and be done for the day.